Hey everyone, welcome to a first video in a class that's meant to kind of give you some training on utilizing computers and your calculator as we're doing engineering problems. And the first thing I want to talk about are vectors, and we're not going to get into the electronics right this minute. I want to do a little bit of a review on some of the concepts that are really important to doing calculations in engineering. The first of these I want to talk about are vectors. So a vector is a quantity that has both magnitude, which means the same as size, right? So magnitude and direction, so it's pointing somewhere. Some really common values in engineering that are vector quantities would include momentum and velocity. Forces are a vector quantity, and there are others. Magnetic fields, electric fields would be vector quantities as well. But the one I really want to get into is displacement. And displacement is a movement from one point to another. Okay, so I'm going to travel from here to here. And so if I start here and I travel to here, then that's a displacement. I can travel the same distance but in a different direction. And if I start at this beginning point, which I'm going to call point A, if I start at A and I travel this length, whatever that length might be, to this point, which I'll call B, then I've gone a certain displacement. Okay, I've gone a certain displacement. In engineering, we like to refer to that as R sub AB. And then we use this symbol over the top of the letter to indicate vectors. There are other symbols that will indicate vectors. This is the one that I'll be using. But you may find, I know I did in my engineering curriculum, that different instructors use different symbols to designate a vector quantity. In your textbook, it's generally designated with a bold-faced letter, right? So I can't do a bold-face on the board, but this is then a displacement from point A to point B. Okay, and in general, the subscript goes from one point to another. There are, again, other designations. I'm just going to say this for now. We'll come back to it in later courses, actually. I might write this as R sub B slash A. And what that means is the position of B with respect to A. So if I'm at point A and I point to somebody at point B, that's the direction I'm going to point. And then the distance from me to them is going to be their position with respect to me. Right? Now their position with respect to somebody at point C is going to be different. They haven't moved. They're in the same place. But their position with respect to me is different than their position with respect to this person at point C. So just a different designation. Save that for another day. Okay, for now, I'm just going to use the designation from A to B. Okay, so from A to B. All right, so this is the vector then from A to B. So I'm going to just designate that R sub AB and put that over the top. All right, now, vectors, again, a magnitude and a direction. Now, if I'm talking about displacement, usually I'm going to talk about this in terms of length. And I'm not going to worry about that right now, but it's going to have some length. Well, what if I travel in the same direction, but I go farther? Then I would have a bigger vector. So let's say I had traveled not just to B, but I kept on going to this point up here, which I'll designate D because I've already got a C down there. Along the same direction, pardon my crooked arrow, it's along the same direction. Let's assume it's the same length. So A to B is the same length as B to D. Okay, it's the same length. And so if I refer to this vector instead of R sub AB, let me just call it L, then this is also L. The two vectors are the same size and pointing in the same direction. Now, I've traveled from A to B, I've traveled L, and I've traveled from B to D, and I've traveled L. So I've added those together. So I've traveled this total distance. And think about it, the reason I use displacement is because you can do this. You can walk outside, and you'll be displacing yourself as you move from one point to another, right? So move from here to here. There's been some displacement. So I traveled L, and then I traveled L again. So my net displacement from A to D is 2L. Right? So from there to there, that's a total vector of 2L. So I traveled L, and I traveled L again. So and means plus. So I travel L again. And when I add those together, I have two L's, right? So I have doubled just the vector quantity L. I traveled twice that quantity. Okay? And so vectors will add together. We can add vectors together. Well, let's say, for example, then I travel L, right, from A to B, and then let me travel back again. Okay, I'm going to get rid of this for a second. I travel back. I'm going in the opposite direction, 180 degrees in the opposite direction, but the exact same length. So since it's in the opposite direction, I designate that as minus L. Same magnitude, but 180 degrees opposite. Okay, so exactly the opposite direction. So I'm back to where I started from. So my net displacement in that scenario is 0. And so L plus negative L gets me back to 0. Well, this works just like numbers have. Right? It's the same idea as we had just working with standard numbers. So vectors will add and they'll subtract. They'll add and they'll subtract. In a similar fashion, let me move over here a little bit. So let me travel along some vector quantity. I'll actually point it differently. Let's say I go from here to here. Okay, so I'm traveling from this point to that point. I'm not even going to designate any sort of letters there, just from this point to that point. And I'm going to call that vector M. And then let's come back this distance, and this might be 1/4 of M vector quantity. So I've traveled 1/4 of M, but in the other direction. So I've gone out M, and I've come back 1/4 M. So minus sign, because it's in the opposite direction, and 1/4 the length. Well, the net result, you might imagine for this, the net result would be this vector right here. And that's going to be 3/4 of M. Okay, so the result comes the other way, right? The result, rather, is along the same one. Of course, I only came back, but we just add the numbers together, right? So if I took a whole x minus 1/4 x, I'd get 3/4 x. We did that with variables in any kind of an algebra class. So this is going to be 3/4 of the vector M. Okay, so they add or double. So this is referred to as multiplying the vector by a scalar. So multiplying by a scalar. Multiply by a scalar. And it doesn't have to be a nice number. I could do it times pi. I could do it by 75.38. Doesn't matter. You multiply a vector by a scalar and you just increased or decreased its length. If it's between 0 and 1, you've made it shorter. If it's from 1 to a larger number, 1 to infinity, you've made it bigger. And if it's negative, you've reversed its direction. Okay, so there's a real simple beginning to the concept of vectors. And we'll move on from here in just a little bit. All right, if you have any questions on this so far, leave them in the comments below.